We're going to start with a presentation by Ms. Nitya Murthy. She's going to talk on Parkinson's disease, and this project is part of a PowerPoint presentation project done by the students of the Neuroscience and Neuroanatomy class, MSc 530, Health Science Institute, and this course is conducted by the Biomedical Science Department. I welcome Ms. Murthy to start her presentation. Thank you.
Thank you.
Introduction, Dr. Kuriakose. As he mentioned, my name is Nitya Murthy. I'm a student in the Biomedical Master's Program, and I'll be giving a presentation on Parkinson's disease. So Parkinson's disease was described as early as 5000 BC in Indian Ayurvedic texts, as well as the Nijang ancient medical Chinese texts. The symptoms of Parkinson's disease include the resting tremor, bradykinesia, which is a slowness of movement, loss of coordination, the freezing of gait, anosmia, which is the loss of smell, difficulty swallowing, and cramping. We have a diagram to the right of the typical posture for a patient with Parkinson's disease. You can notice the tremor of the hands, even at rest, which is very typical Parkinson's disease. It actually gets better when the patient is in movement. Persistent tremors of the hands and legs, the shuffling gait, the unbalanced posture, and the curved steps are all characteristic of this disorder. 1 million people in the US have Parkinson's disease, and 1.5 times more men have this disease than women, and it's more common in Europeans. So the average person with Parkinson's pays around $2,500 a year in just medications, and it costs around $5.6 billion in Social Security money to manage this disease. The reason for that is because it's not often caught until the disease has progressed to a worse state. As you can notice, are pretty typical of common aging symptoms. So it's not caught early, makes the treatment more dire. There are no specific laboratory or imaging tests that can confirm Parkinson's disease. There's no blood tests, and there's no diagnostic imaging tests. A PET scan can be used to examine the activity of the substantia nigra and the basal nuclei. However, this is not commonly done because it's fairly expensive. Oh, thank you. It's fairly expensive and it's not always accurate results. An olfactory test can be used because the loss of smell is one of the first symptoms of Parkinson's. And this happens because there's an accumulation of alpha-synuclein protein in the olfactory bulb. The accumulation of this protein happens not always in the brain at first. So if a person notices a lack of smell, the indication of this disease. However, most importantly, it's a family history that diagnoses disease. Presenting with tremors would go to the neurologist and he would ask the patient if their parents or grandparents had this kind of symptoms. And if that was the case, then it's most likely Parkinson's. A levodopa test can be used as well, which is the prescription of the levodopa medication in response to these symptoms. And if the symptoms are alleviated, then it's a pretty sure bet that it is Parkinson's. And it is diagnosed mostly by symptoms and the characteristic resting tremors. About the normal neuroanatomy of the brain and the part of the brain that's affected by this disorder. So the basal ganglia are a group of 4 nuclei which are involved in communication with the cerebral cortex and thalamus in order to coordinate voluntary motor control, procedural learning, and to smooth muscle movements. The basal ganglia are 4 nuclei, as I mentioned, but the nuclei of interest are the striatum and the substantia nigra. They are the ones that are most affected by this disease. The striatal output pathways, both direct and indirect, are controlled by dopamine secretion from the substantia nigra. The striatal output leads to inhibition of the thalamocortical neurons, which leads to control of movements initiated in the cortex. The striatum is responsible for balance, coordination, and walking. So we're going to look at that in a little bit more detail. We have here a diagram of the brain, the substantia nigra, which is what gets degenerated as the disease progresses. So in this diagram, we see what the normal interplay between the basal ganglia should look like. Dopaminergic secretions in the substantia nigra communicate with the striatum, which in turn communicates with the globus pallidus, which is another one of the basal ganglia nuclei. Communicates with the thalamus, which coordinates with the motor cortex.
Come closer.
And we have that pathway written out in a flow chart, so you can see how that goes. The substantia nigra releases dopamine, which communicates with the striatum. This communicates with the globus pallidus, which communicates with the thalamus, motor cortex, and that leads to decreased movement if the dopamine is not communicated to the striatum, which is what leads to the condition of muscle movements. Oh, this is working now. Parkinson's disease is a progressive and chronic neurological disorder in which movement is affected. It's caused in most part by a decrease in dopamine synthesis in the brain, and that results in adverse changes in the substantia nigra. It's thought to be caused by loss of neurons that release the dopamine in the basal ganglia. And the loss of particular monoamine transporter type 2, the BMAT transporters binding. So there are three types of dopamine transporters, the D1, the D2, and the D3, which are found on a subset of cells in the striatum, in the cerebral cortex, and the substantia nigra. The striatum receives excitatory input from several areas of the cerebral cortex, as well as inhibitory and excitatory input from the dopaminergic cells of the substantia nigra. The actions of both pathways regulate the neuronal output from the striatum, which in turn communicates with the thalamus, then the cerebellum, and then the peripheral nervous system, which is ultimately what causes movement. The cause of Parkinson's disease is largely unknown, but it's thought to be a combination of genetics, environmental factors, which are exposure to certain metals or chemicals, and oxidative stress of aging. The degeneration of cells in the substantia nigra causes neurons of the striatum to fire uncontrollably. This results in improper signaling, which leads to the lack of control of muscles. The pathway that's affected in all of this is called a nigrostriatal pathway. The other big pathology associated with this disease is the presence of Lewy bodies, which sits in the cytoplasm of the remaining dopaminergic neurons. Lewy bodies are just lumps filled with alpha-synuclein protein, and these accumulations in and around the cells leads to cell death of the dopaminergic neurons, which is what actually leads to the lack of dopamine. However, these can only be seen in autopsy, so they can't be detected early. As I was mentioning, we can detect alpha-synuclein protein that's not in the brain early, so if we do catch that, then that can be a useful diagnosis of Parkinson's disease. The genes that are associated with the disease are SNCA, PRKN, LRRK2. So mutations in these genes have been involved in Parkinson's disease, so there's research being done on catching mutations in the genes early as well with individuals with family histories of Parkinson's. Treatment is levodopa medication, which is converted to dopamine in the brain. It's the most common treatment for Parkinson's. It's often combined with carbidopa in order to enhance its benefits and control the side effects of levodopa. So what unfortunately happens is that the long-term use of levodopa leads to a wear-off situation in which the symptoms of Parkinson's are actually limited again by the use of levodopa. So other chemicals are used to combat that. Chemical methyl transferase inhibitors, dopamine agonists, and non-dopaminergic therapy are utilized. And they're combined with MAOI inhibitors to manage the levodopa-induced lesions. So all in all, this is a devastating disease. It affects a large percentage of the population. And it's not often treated early because it just means the signs of aging early on. And there's not much research being done in the elderly folk of the world. So with early management, with early treatment, it can be managed more regularly, but it is chronic and it does get worse over time. these are my references.
That was very good. Thanks a lot, Nitya. And now the floor is open for all the questions. Yeah. Okay. So I'm just going to turn the. All right. Okay. So that's the audience. I don't see you, Rick.
I'm here.
All right. Okay. Now I can.
I tell you, it's a rough-looking crowd.
All right, okay, so we're going to take some questions now. Okay, let's start with the questions. So, this side, Rosa. Can you talk loudly because...
Yeah, repeat the question, Sajish.
Levodopa medication is used to treat Parkinson's, which is just giving dopamine to the brain because there's a lack of it.
Right, so the question was regarding the medication, the treatment for Parkinson's disease. Okay, any other question? Mohammed? Yep.
What age does it?
Okay, the question is, what age does it start? Does the disease start?
It can start being manifested in the late 50s, early 60s, and it gets worse over time.
I'm curious about the Lewy bodies. You said they're only able to be detected during autopsy. They present themselves, they look more like lesions, or are they spotty? Like what distinguishes them?
So they're like clumps. They and they're masses that are found accumulated in the subsection where there should be cells.
Right.
So if you do a cross section of the brain on autopsy, you would see like actual physical clumps. I think they're darkly colored, is what I was reading.
Thank you.
My question has to do with, you mentioned that there were more people in Europe affected by Parkinson's disease than in other countries. Can you explain why?
There's not really so much of a racial bias in that way. It's just that people like people of European descent have like lived and there is a genetic basis to this, so they have mated with each other.
So you're saying European descent or Europe versus the U.S.?
European descent.
European descent.
Yes, it's not really geographically confined.
You mentioned several markers, genetic markers, for the disorder.
Mm-hmm.
What do these specific genes code for? What are they responsible for the neurotransmitter? The levodopa conversion enzymes and other enzymatic intermediates and pathways.
So I know one of them. The essence CA gene codes for the alpha-synuclein protein. So overexpression of that gene leads to the accumulation of that protein. I'm not sure about the others.
Okay, what is synuclein?
I'm not sure.
Okay.
Okay.
Right. Mohammed, can you hold this for a minute?
Sure. Which direction should I be facing?
Any more questions? All right, okay, I have a question. Yes. Right, okay, so the treatment of Parkinson's is levodopa. And the whole idea is to get the dopamine into the substantia nigra, right? Okay, so that's what the problem is. So where do you see the research going in this particular disease? You said that you take carbidopa. Why does not carbidopa reach the brain? Is there something that prevents it, or what happens?
Well, I know that there's research being done to improve the dopamine receptors. So I think carbidopa is one of the things that improves the receptors. So that better allows the levodopa to actually bind.
Right. So the question is, why doesn't you said after a certain period, carbidopa loses its potency, right? Why? Why is that?
I think the brain brain just gets used to, or the levodopa loses its potency, and I think it's because the brain just gets used to it, and then it needs more and more. So if you increase the dose of levodopa too much, as it needs over time, that actually causes dyskinesia, which is Parkinson-like symptoms, which is counteractive to what you're trying to do.
Right. And on top of that, there are some enzymes in the periphery, because you're taking it as a tablet, and there are some enzymes in the periphery which breaks it down and does not allow it to go. So that's another problem which is happening. The other thing is that the brain develops some kind of, they lose the sensitivity. Tolerance starts to tolerance. And so what do you see the treatment doing now, putting two and two together?
I think there's a good amount of research being done on the alpha-synuclein accumulations, because if catching the disease early leads to better treatment.
Yeah.
I'm not sure what's being done to improve the potency of the dope over time.
Right, okay. What else do you think can happen?
Better medications that
Another
don't get,
medication,
yeah.
or put it straight into the brain, right? Rather than going through the peripheral route and having the enzymes break it down.
So something that can cross the blood-brain barrier.
Blood-brain barrier, yeah. So the blood-brain barrier is really one of the things that prevents it, and it's really the effects of blood-brain barrier. Yeah. Okay, that was an excellent presentation. Thank you very much. And thanks a lot for everybody. Thanks a lot for the evaluators. We have Dr. Morose, Paris, we have Stephanie, we have Sharon Argo, we have all our students in the 5:30, and I want to say thanks to each and every one of them, and a big thanks to Nitya, and let's give her a big hand. Thank you. Okay, John, we are done.
Thank you.